Nate, shall we jump into the terminal and take a look at the critical path?
Absolutely. We've covered some tools in our troubleshooting episodes and whatnot, and this is going to feel a lot like some of those episodes because we're going to go over some tools about how you can look at memory usage on your system and kind of get an idea of what's going on. So, first of all, I always start basic. I used this tool a ton as a system administrator because it's easy to remember, type quickly, and it gives a good snapshot of what's going on right now with memory on your system. And that's just the command free. It's basically you could say what's my free memory at the moment, right? But of course, it's showing you more than just your free memory. It shows you your total, it shows you your swap, it shows you used and your free memory. And of course, it also goes into buffers and cache. Older versions of this tool didn't include buffers and cache. You had to kind of like, or it did, but it wasn't as obvious. So you had to do some math to figure out what you actually had available. It's better now. They've improved it. Also, you might notice these numbers are very large. That's because it's displayed in kilobytes. We can do free dash M to show megabytes. I think dash G also works to show gigabytes, but I like free dash H, which is human readable. It puts it in the most logical unit based on the size of the number that it's trying to display. So you can see the total is listed in gigabytes or gibibytes, I guess is what I'm supposed to be saying here. And used is in megabytes or however you pronounce that now, because the number, of course, is in meg instead of in gig. So that's one good useful tool. Another one that gives you a lot of the same information, but more of it is called VMstat. If you're familiar with the tool IOstat, which does this for disks, it does this for memory, right? So VM for virtual memory, stat. And you can see right there, it gives you basically the same kind of information, but it gives you some additional stuff here, right? There's these additional information about swap in and swap out. There's information about IO, memory IO, system, and CPU, right? This is more like load averages and weights and whatnot. And of course, this also has some nice, useful command line options. Telling it to display in meg versus k is two characters instead of one, like it is on free, but it's vm stat dash capital S and then an M says display it in meg. Makes the numbers easier to read. There's also a different format you can display it in, vmstat S, which gives you this sort of longer list and better descriptions as to what all those abbreviations mean. So maybe you like this a little better. Maybe it's easier to read. And there's also a way, if you remember, IOstat gives you like this point in time snapshot, but it can also do it every couple of seconds. So you can see what's going on with the system. VMstat will let you do that too. If I do VMstat and then the number 2, which tells it to run every 2 seconds, and then another number, which is the number of times it should run. So this will run every 2 seconds for 15 instances, 15 runs, right? That's going to give us a running tally of what's going on our system. And on this particular system, this isn't going to change much because it's just a lab system. There's nothing going on this machine. So you're not going to see the memory footprint change all that much. You might see little bits as the operating system is doing things in and out. Anything about VMstat you'd like to share, Scott? I know you use this tool a lot more than me. I was always a free person because I'm simple.
VMstat is really handy when you've discovered something with free or by running just VMstat on its own. You're looking at aggregate system data, but you want to know more about what the system's doing now. Running it as a series of runs is important because
Right.
when you ran it, you got the system aggregate first, but then each run after that was the window of what had changed in the last 2 seconds. Uh, I've noticed a bunch of people online recently asking about, it's like using swap, okay, but are you really using swap? Like, what did your swap in and swap out look like? So if you're running VMstat over a series, you can actually see, is it actually performing swap operations? Or
Right.
is this the stuff that's been swapped out over time and just kind of in long-term holding out and swap, right? If it's swapping in and out significantly in a short period of time, that's concerning. If there's really not swap activity happening, but there's a bunch of stuff there, that's less concerning.
Now you could use free with the watch command, but now you're chaining commands. It doesn't give you that tally. VMstat gave it to you row by row, where running free gives it to you in one block, and every time you run it, it would overwrite that block. So handy tool. Good to have several tools to do the same thing depending on what you're looking for. Really, the way, kind of the Linux way, right? Let's give you 28 tools to do the same thing. All of them work slightly differently and might be beneficial in different use cases. So the next thing I wanted to talk was PS, which of course is how you look at processes that are running on a Linux machine. Just plain old PS gives you what this current user is running, like what's running is this user. PSAUX is, sorry, AUX, not WX, is a common command. You've probably done this a million times if you're a systems administrator. It shows all the processes and gives you some extended information and what users they're running as. And there you go. This will show me, because I'm running it as root, it'll show me all the details about the processes running on this particular lab system. If you run this as a user, it gives you the same list, but it doesn't give you all of the output because you don't have permissions to read some of it, right? So just keep that in mind. Um, a couple columns I wanted to focus on. There's this RSS column, which is not RSS like, you're pulling in your newsfeed. This is RSS, which is the physical memory that this process is using. So this is a chunk of physical memory allocated to this process that takes up this much space. This is the virtual memory footprint. Some people synonymize swap and virtual memory. In this case, it's actually more like this is memory that this process can expand into. When the process starts up, it says, this is my virtual memory footprint, and this is how much I'm actually using. That may end up in swap. It may not end up in swap, right? This system, because it's a lab machine, doesn't have any swap. So that virtual memory can't be swapped. It's actually a virtual allocation within the block of memory, which could be a problem if we over allocate the system and all processes try to use that. That's what swap's for. Since this is a critical path, we're going to move along quickly. For the next thing, let me switch my share here. All right, so this is actually in my home lab, and the reason I wanted to switch to this machine because it has more going on. It's running Podman containers, a bunch of VMs. So there's a bunch more things going on in memory, a bunch more processes running. And you'll notice I'm running these as a normal user because this data can be collected as a normal user. The first thing I wanted to show you was top. Again, top is, if you're not familiar with top, I don't know what you're doing with your life, because top is like I would say every system administrator's go-to for what the heck is going on right now in my system. And of course, this gives you things like load average. It gives you some statistics on memory, and it gives you this like constantly updated screen, or the constantly updated output that will update. I think it's every second, 22 seconds, something like that. Now, the reason I wanted to do this command on this machine is because our lab machines only have one CPU. This one has 12. If you hit number 1 while looking at top, it'll show a breakdown of every single CPU and what's running. This isn't necessarily memory related, although some of it is really helpful when you're thinking about performance, because it gives you all these columns about user space and system and disk weight and idle time. Really helpful stuff. But when we're talking about memory, of course, you're going to want to look at these columns down here where it says virtual memory, resident memory, shared memory, things like that. And of course, how much CPU this particular process is taking up. You can see Cockpit is taking up a whole CPU, probably because I'm running this session through Cockpit, right? So top, really handy tool. Any words of wisdom with top before I close, Scott?
Srinath notes that your load average is about 4. That is not necessarily a bad thing.
Right. That
Things
just
can
means
be
I'm using CPUs on this machine. Because it's a multi-core system, the load average is misleading. If you've been in this game long enough that you remember single-threaded or single CPU systems, you would remember a load average of 1 was usually synonymous with a system that is overloaded. It has 100% of one CPU in use. That's not the way load average translates in a multi-CPU system. Correct me if I'm wrong here, Scott, but this comes down to the number of processes waiting for CPU. Is that
Yeah, it's the average CPU run queue depth.
run queue depth? So if I have 12 cores, a run queue depth of 12 would mean all my cores are doing something, right? And of course, that load average goes across time. So if it stayed that way, or if it went to 40 and it stayed there, that means there's a ton of things that are waiting for CPU in my system, right? So again, the load average of 2.5 or 2.8 or whatever on my system doesn't really indicate a problem. It just means that there's things running on the 12 cores that I've got available.
I disagree slightly with your assessment. If you had 12 cores and all 12 were doing something, the run queue would be 0, right? Because they're all running. They're not queued up running, queued up waiting. There's a lot of things that get you in the CPU run queue that are not necessarily a bad thing. When I've seen huge CPU run queue depths, it's actually pointed to disk I/O problems, not CPU problems. So things like processes will check periodically and will have to be run on the CPU to be checked periodically to see if their IO requests have been resolved. And so they might hang out in the run queue, just cycling through to see if that thing has been resolved, which is how if you have disk problems, all of a sudden you have a huge CPU run queue depth.
Speaking of disk IO, that's the reason I like this view that I'm showing right now, where I had expanded it to show all my cores. I said 12 cores before. There's 16 cores in this machine. You see the 0.0 WA. Some of them are like 0.3, 0. Whatever. That's the disk weight for that particular core. So the process running on that core, how much time it's spending waiting for disk. Okay, so anyway, the point is, if all your CPUs or a number of your CPUs are waiting on disk, that could indicate a disk usage problem, or a disk not usage, but a disk IO problem. Especially if you got like network attached disks or SAN attached disks or whatever. That could indicate a network or disk throughput problem. Okay, the last thing I wanted to show was the command swapon. This tool does a number of things. If I were adding a new swap disk, I would use swapon to activate it. But if I want to just view the swap usage, just swap, I can do swapon-s. This will tell me these are the swap disks, the swap devices that I have. The reason I use this machine is because it has a physical disk here for swap, which is usually the way you would do this. And of course, it tells me the size of that swap and how much of it's used. You might notice there's like all of my swap used, but I think we're going to talk about that a little more in the deeper dive.